just over 1,400. Would it be impossible to build the largest bridge? Is it impossible to Europe and Africa? The largest ships in the world today are aircraft carriers. But a ship 5 times their size? Impossible. Or is it? In fact, all of these projects are already on the drawing boards. If built, achievements of historic, but they would also present unprecedented challenges. Really be built. And could they withstand the impossible? Kong. And growing fast. It's bursting at the seams. By the year, Hong Kong's population. Where will these people live? Problem. Tokyo, New York, Jakarta, Taipei. All of the century.
The pressure is enormous. I mean, people cannot move in those. Growing massively.
If they keep growing, we'll need 15 new cities a year, each housing 12 million people. That's 15 new Los Angeleses every 50 years. But there's simply no room left for that kind of urban sprawl. There's only one place to go. This is the on the planet. Millennium Tower. It would stand twice a half-mile high. Over 60,000 people would live or work here. A city within a city. Many designers think it represents the best solution for explosion. Structure ever really be built? It would cost $10 billion. It would consume more building. A decade. On such a seemingly impossible task is architect David.
It would be a massive, and it would be a world. Realize it, resources would have to come from the whole, all of the globe, Europe, America, Asia, all brought together. The challenge would be to realize one of the world's largest.
If built, Millennium would be a staggering 100. But a project of this scale would encounter enormous The first problem millennium is where to put it. By in Hong Kong. But the design team, they decided to put the tower out in the harbor. Millennium's other Andy Miller.
To the harbour or into not using up any more land, and what you could possibly do is then around the base of the building.
If it could be done, Millennium limited land base instead of consume it. But there was another problem. Earthquakes. What would happen to Millennium if a big one struck Hong Kong? How would such a tremendous structure stand up to a major tremor? It's a crucial question. Is unknown territory. A single unforeseen mistake might mean so the design team will draw on centuries of engineering know-how in order to make the building safe. Probably the earliest attempts at At 500 feet tall, this one is impressive for the period. But the pyramids are somewhat impractical. And workers toiled for days. 2.5 million stone blocks. And when completed, there was room for only one occupant. And he was dead. Things didn't change. Through all that time, the essential stone and brick. Limitations. Stone buildings have to support themselves. The taller a building, nothing. So 5 stories was about the. Then, suddenly, everything changed. Somebody invented steel. His name was Henry Bessemer. He perfected the Bessemer steel converter, which could make 30 tons of high-grade steel in half an hour. Stronger than stone, and it was lighter. Now engineers could make a super light skeleton for a building. Quite. One more problem to be solved. Even if you could build, who would ever climb? Happily, in 1853, Otis had a brilliant insight. He knew that industrial titans would covet those top floors, as the down like gods on the just the chariot to take them to those rarefied. The the race for the sky. The first steel skeleton skyscraper was Chicago's home insurance building in 1885. The building was completed in 1902. At 22 stories, sightseers. By the late 20s, the streets of Manhattan had sprouted nearly 200 buildings at least as high. The Chrysler Building was finished in 1930. Briefly, it was overtaken in 1931 by the Empire. At a staggering 50 feet, it became a symbol of 20th century optimism. Put our hearts and minds to it was impossible. The rest of the century, city skylines grew to and a new word was born: skies. Of course, never ends. The tallest building is Malaysia's Petronas Towers in Kuala Lumpur. 7. The slender towers are shaped and they stand 1,483 feet if you include the spire. For greater height, the simple human drive to rise to the challenge.
And as I forward, building higher, longer, doing things that stretch the imagination, something that time.
And yet, as they stretch ever higher, papers remain old-fashioned. Of ironworkers. Millennium's construction would bring in workers from all over the world than any have ever and snap. These men are working in Chicago. Scrapers. This kind of work isn't for everyone.
You don't know if you can do it until you try it. To be up here.
5-ton girders into position while dangling thousands of feet up in the air. The only way to get around up here is to walk on those same narrow beams. That not everybody makes it to the retirement party.
At all times, you could be killed, or hurt, maimed.
Dangerous. These were strict rules. For instance, the safe way to get around on the beams is to straddle them. But it's an awkward thing to do. So sometimes the workers will just scamper across. It saves time and an aching back. But one slip, and it's an express ride to the ground floor. Ironworkers literally stitch the building together, one piece at a time. 2 beams together, 100 stories in the air. Top, there's nothing to hook onto. iron. All the hard hats do, one new technology with critical decisions. The project from falling behind.
To make it fit.
As long as
Oh, I can look at the
these work on something as meaty as Millennium Tower.
It's nice. Sharp. It's good. It's state of the art.
And Millennium will need that. Project would also require entirely new construction. Building engineers have already begun to. Most ingenious systems now in use is called the. Designed by Obayashi of Japan, firms, skyscrapers with the. A weatherproof enclosure is built around a suite of robotic cranes and. The building's structural steel segments are. Every piece is labeled with its final position in the building. Guided by a program, a set of cranes. Then the pieces are transferred to a second. Moves them to their final location. Easily bolt them together from the safety of a support platform. When one level is completed, the entire self-rising factory starts again. It becomes the building's roof. On top of the tower's center core, which will house mechanical systems. The outer ring of the building, the living and working areas, will be built the old-fashioned way. Half a mile above Hong Kong Harbor, from a simple form that. But even with state-of-the-art construction techniques, Millennium Tower will still be an enormously complex project. It will concrete, steel, and glass. Disruptions to the global supply.
Because of the scale of it, something like Millennium Tower would use the entire steel production a year plus. Build any cars, they wouldn't be able to build any hi-fis or anything. The flow of materials to the site would have to come from global sources. It couldn't literally come from any one region.
And since global endeavor, the completion of the tower would be cause for a global celebration. It looks like fun. So elevators are kept to more earthly speeds to keep passengers on their feet. And that's not the only challenge Millennium could present to the physicists. Because Millennium will do something all skyscrapers do. Sway. And it nearly it'll get hit with the most powerful winds on. Skyscrapers need to sway to high-altitude winds. This is a matter of design.
Starting with a rectilinear. The performance under wind conditions, particularly high-speed winds at high level, and this rectangular form or square form really is very difficult in terms of the airflow around it. It creates
The problem with a rectangular shape is that it presents too much head-on resistance. What's the best solution? University of Science and Technology boasts one of the world's most advanced wind tunnel laboratories.
Now the 3/4 speed.
A leading expert on the effects of wind on is Dr. Kenny Kwok.
If you build a rather conventional square, expect it to exhibit very, very large response, particularly in the crosswind direction.
A rectangular building produces wind vortices. Those vortices are whirlpools of air that building, pushing.
I'm gonna pull it back, man.
Nelson next considered a that's uniformly round from top to bottom. Wind flows more easily. Its constant diameter from creates problems.
In order to keep the
shape is constant from top to bottom, that vortex accumulates together, and that puts massive force.
A cone shape eliminates that problem by varying its diameter along the full length of.
For the Millennium Tower, continuously, so that the vortex shedding pattern changes according to the diameter of the building, which changes.
Even shape proves remarkably.
Nothing much is happening. Yeah, it's about
And Millennium shape isn't the only thing. It will also use a surprisingly simple device that's already a tuned mass
simulation looking at the effect of different dampers, how it controls the building vibration. Cool structures. See, that would take a little while for. If I stop that for a moment. Twin liquid column damper, the shape on the container and the liquid column, the liquid will oscillate the structure itself. Therefore, if I give it a deflection, the one with the damper
dampers, by creating vibration of the sway, tend to cancel out the building's movement. And they're not. they're also crucial in stabilizing the building during an earthquake.
We have two identical buildings, and you can see that both buildings undergo vigorous vibration. Introduced here is a slot, and I subjected to the same excitation like before. You can see the building with the twin sloshing damper undergo much smaller vibration compared with the building without the twin sloshing damper.
The shock waves created by an earthquake vibrate the ground at a buildings around 10 stories frequency, which is what causes the damage. Because a taller building has it shakes much less in an earthquake. Engineers are hoping that the tower is so tall it'll in theory, Millennium will be one of the safest buildings. In theory. But Millennium's designers will by one of the biggest earthquakes ever recorded. 8.6 on the Richter scale. Millennium is shaken, but it survives. Millennium is something. Things that seem impossible today. The engineering problems have, for the most part, already been solved. Our achievement by our imaginations. Those who dare to dream big are often called mad. He wants to build a ship 5 times larger than any ship ever built. Its name is Freedom Ship. If Nixon can build it, Freedom Ship will be long, 3 blocks wide. The cost? At $11 billion. Freedom Ship is so huge it would need to be built at sea. Thousands of workers would toil for over 3 years to complete it. And when finished, it would weigh nearly 3 million tons. The tallest structure in Denmark did a ship on this scale. Is Norman Nixon's dream impossible? And even if Freedom Ship could be built, there's a deeper question. City. The boat. What he wanted was to create a private community on a Caribbean island.
An island in the Turks and Caicos called East Caicos Island. But they had a local election. So for another island, and some people suggested that we build a floating city. And we weren't too interested in a floating city. Brought up the idea of moving this floating city from one country to another, so you were setting offshore at different countries. So it eventually evolved from a floating city into an actual ship. We could sail from, and this created, and it's a lifestyle that doesn't exist in today's world.
Nixon became fixated on the idea. Something completely new. A city at sea.
Is one that gives you the opportunity to work and it takes for you to live a good lifestyle on the ship and still travel. Strongly that we do have a market. No question about it.
At a day-long seminar, Nixon and project to potential investors. People have come from around the world to hear the pitch.
Freedom Ship is and a true departure from anything that currently exists.
The speakers fabulous place to live and work.
Never changed to this day.
But there's that freedom. If they can't prove that, they won't begin construction.
Economics dictate we're wasting our time.
I'd like for you guys to look this over and give me some comments.
To pay for itself, house over 30,000 residents, some in multi-million-dollar condos. It would need a private school and hospital. The ship had to accommodate 16,000 workers and at least 30,000 visitors a day. It would need hundreds of businesses like restaurants, supermarkets, and Freedom's top speed is only. It would need an airport for corporate jets and tourist ferries.
Calculated the square footage they would need, and then we backed into the size of the ship. If we have this community, then we have something that is economically feasible.
Computer center in there too.
For Freedom Ship to had to be large. Very large. Well, many of history's biggest vessels, the Titanic, the Queen Mary, and the supertanker Yare Viking, comfortably inside, created something of a credibility problem for its design.
Probably the largest challenge associated with Freedom Ship is to overcome people's impression that this ship is so large that it can't be built.
30 feet here, so we got 30, 60, 120 feet all the way up to here.
Question.
And
Is one thing, but the real ship could be built. Here in Italy, the thin state-of-the-art technology to craft the world's most glamorous cruise ships. Incredibly expensive to be custom-made, shaped like long, thin wedges to help them slice through the water quickly. And the curved pieces of steel that make up that wedge can't be ordered from a catalog. They have at a time. Then they're welded together by multi-million-dollar robotic machines into huge modular sections. The sections are hoisted, dropped into place. final assembly of the ship takes place on a dry and the ship is floated out to sea. Modern shipbuilding methods have they won't work for Norman Nixon and his Freedom Ship.
We can't square foot. And at that level, it just wasn't economically feasible.
Freedom Ship would cost so much to build, hardly anyone could afford to live on it. Nixon needed to find a cheaper way, so he abandoned traditional shipbuilding for large floating objects. The largest floating object in the world today, it's an airport. It began when a Megafloat Airport is currently moored in Tokyo, half a mile long and over 200 feet wide. The concept behind Megafloat is surprisingly simple. It's a gigantic barge, boxes, welded together to form an enormous platform to position and then because Megafloat is constructed out of simple off-the-shelf to build.
Entirely, instead of following
Nixon may need to build
in which you design every piece of steel in a particular manner for a particular location. We decided that we would go. So steel is actually very cheap.
Nixon wondered, could he from prefab parts? If he could, he'd eliminate steel, and his construction costs would.
For us, it works quite well. We got it down to like $400 per square foot. We had something that was economically feasible.
Parts. Freedom Ship just might work. The cable system, so big, no dry dock in the world could hold it during assembled in the water. The location of choice turned out to be the Central American nation of Honduras.
Bay called the Bay of Trujillo in Honduras, and 4 miles of protected water. There's very little. It turns out this is an excellent location. It's not far from the U.S. located.
This will be our first set of railings that we put in here in the center to slide the comm modules in. We'll add additional railings here and additional railings here.
400 feet long, and we slide to the water. We bolt them together until we have the base of the ship.
Freedom's enormous base, 100 steel cells up to 60 feet wide, 120 feet long, stories tall. Would consume vast quantities of just about everything.
3 million tons. So we use steel from 4 or 5 different countries. Another one of the largest products we use is in a period of 2 years we're going to be one of the world's largest purchasers of drywall. We've got several. We're going to be buying this from
to ensure an uninterrupted flow of material walking across even the simple. Nixon won't be able to. Freedom's motors will be state-of-the-art. In fact, they'll more closely resemble jet engines than ship. How far the art of seamanship is Noah's Ark. For early seafaring Greeks and Romans, ships got around using wind power and manpower, and those sufficed for centuries. Then something happened that changed shipping forever. The steam engine. In 1807, inventor Robert Fulton built the first successful 12 years later, the first that traveled by ship was never the same. The 20th century like the Queen Mary and the Queen Elizabeth could cruise all day and night at a brisk 20 knots, powered by efficient steam. Nuclear power came on after World War II. It was too expensive for commercial ships, but large Navy ships adopted in use. Today, virtually all screw propellers. Technology is reliable, but it has drawbacks. The engines take up a lot of space in the belly, are fixed in place, making the ship awkward to maneuver. But Freedom Ship will change all that. It'll utilize a brand new propulsion, small electric motors, own pod. The need for a huge engine room inside the ship. 20 degrees. The ship can move in any direction. The captain controls everything. Will deliver 30,000, cost over $5 million. But even with 100 ships on the seas, because of its 3 million.
In our case, speed is not really that important. We circle the world, but it takes us 2 years to make one revolution. Our particular philosophy would not work with someone who's building a ship, but for us it works quite well.
Because Freedom Ship doesn't need to go fast. It will slowly circle the globe. Guests can come and go as they wish on one of the many daily. But Freedom will need, and so she'll have to be. The year is 2010. Magnitude 8 earthquake has just set off a massive tsunami racing out in all directions at 600 miles an hour. The wave is a monster. especially the lumbering Freedom Ship. And place imaginable. Water off the Canadian coast, just a few hundred miles from the earthquake. Out at sea, a tsunami is nearly invisible to the Its gigantic swell is able to spread out over a large area. But forces the wave up. Results. The massive destruction to coastal. One of the worst tsunamis in history. 1993. An earthquake measuring 7.25 inch thick. Japan has endured these. Sometimes, the wall of water can crest over 100 feet. On Okushiri, destroyed, killed. Ruptured gas lines caused in the blink of an eye, nature's island to rubble. Back on Freedom Ship, a radio alert has just come in, and the captain swings into action.
Seems like that we are in collision course.
Ship from impending disaster. But he may not have. The captain needs to get Freedom Ship out of the shallow water it's in and out to sea. Less impact. But and the death wave is racing toward it at 600 miles an hour. Freedom withstand the impact? Nobody knows, because the ship was simply too. Many new ship designs are tested. Each tower would then in Bethesda, Maryland. The size of a professional shape through precisely controlled, perfect storm.
The thing you want is test a model of a ship under conditions where you would never put a real ship. Because if you do it, it's going to die.
These swells sensor data about the ship's roll. Control booth. Operators with different sized. The data will then be.
We can look at the operability of a model. Capsize risk. We can look at seasickness. We can look at lateral accelerations, which might mean
designers. The slightest alteration can mean the difference between a vessel and one that could sink like a rock. Wave action can actually cause a ship to vibrate to withstand this vibration, or it could buckle.
1.5?
Yep.
Down at 10 knots.
Throttling down.
Okay, let's try Freedom Ship then, Brad.
Today, the facility will try to analyze Freedom computer model. But the ship's dimensions are so large, the computer...
It's not going to work. Right now, we clearly sideward movement of the ship shallower than what we're used to.
Even really test the Freedom Ship. Yes.
See, this is going to be a 3-story casino. Okay. That is the most valuable
than a dream.
That hasn't been done before. People who say you can't do it.
Someone already. Nearly all of his 86 years, architect Jacques Fresco has been those structures all derive.
When I was about 12 years old, I was looking on the table. I think all like that, I don't think they come out of nowhere.
Fresco will be forced to colonize the sea if inevitable.
So many people. And if the population exceeds the capacity of the land,
3 towers sitting
seaward and build cities throughout the
working from his Florida studio types. Lives in one. Fresco's even transporting his structures out to sea. Out of modular sections. On land by robots. Then towed to their final ocean.
Except when it rains.
Memory metal.
These memory metals can be distorted, twisted, pulled out of shape. And then when a certain temperature is provided, that memory metal original shape.
So buildings made from memory metals can be compressed into small cubes for towing and then snapped back to size upon arrival.
And almost instantaneously, you will see it at all.
Fresco's vision goes beyond architecture. He sees his cities as tools for fostering humanistic values.
I feel that environment shapes our values. Know the people we identify with. What will drive people in the future? A world without hatred, without bigotry, without prejudice. Extend an invitation for all people to join in because the problems affect everybody.
But the problems affecting Freedom Ship right now. On the bridge, the captain pushes Freedom's 100 motor. He needs to deep water. where the killer tsunami can't destroy his ship. Has less than 100 feet, and the wave is 600 miles per hour. Ship will get her test after all. The impact. 3 million tons of scrap metal on the ocean floor. Badly shaken, but she holds, has passed the test this time. Floating cities like Freedom Ship may prove those who dream big price. Other types of floating cities like frescoes may be a more populations. Although both may seem fantastic today, visionaries everywhere are enviable. Of years, the continents of Europe and Africa have engineers began to dream of rejoining those two continents with a bridge connecting Morocco in northern Africa. Water earthquake that registered southern Europe across all the way down to the tip of Africa.
Connect people across. Great wars to separate them. Connect the people together.
Would it be possible? A bridge across the Gibraltar Straits would have to be at least 3 times taller and 6 times heavier than any bridge ever built.
The question of, is the Gibraltar Bridge possible, has been raised time and time again. And it's a perfectly valid question. Possible is to build it.
The engineers wanted to put the bridge in the most logical, as in a suspension bridge. It's our narrowest. It will mean a bridge spanning 90, much longer than any other bridge. Problem. The water here is up to half a mile deep. That meant that the bridge would need to be its tallest skyscraper. Even if they could be built, the supertankers that crisscross the strait, and if one of them collided with one of the piers, it could be a major disaster. So a Gibraltar Bridge seemed an important, brilliant bridge builder at the sea floor. But it's gonna take... He noticed something that all the others had. That meant that the bridge's tallest pier, the length. A bridge across the possible. The man who could why Lin came to the with a vision.
I think wild things, see, from a human point of view. See, I had the tech and know how to put things together and make it happen.
Lin The distance between the center tower and just over 3 miles, with another 1.25 miles to each shore. Engineer Mark Ketchum.
Willing to think big. Scale has never scared him.
The scale of Gibraltar Bridge dwarfs any other bridge ever built. The towers would soar twice as high as the tall. It would take up to 10 years and cost up to $15 billion to build the bridge, making it the largest construction project ever. Chuck Syme is the proposed Gibraltar Bridge. Bridge collapse?
More cables than any bridge ever built. It is.
If the Gibraltar Bridge downtown Brooklyn, sail over Manhattan, and wind up in New Jersey. Building a bridge is far more difficult than other kinds of construction because it takes place on water. The first part of building the 3 underwater piers, each as tall and wide as a sky. As hollow concrete shells like these. They would be built on to sea. The piers would be guided into place with the help of global positioning satellites, then slowly sunk to the bottom. Was successfully positioned of its target. But the pier long. The center pier of the Gibraltar Bridge would be more higher. Could answer would come from offshore oil drilling platforms of piers that go down 11 almost as pier. The piers like those of bridges.
Inefficient and
size of a skyscraper in 1,000 feet of fast-moving, ordinarily dangerous. In 1979, it imploded as it was being positioned in the North. It caused an underwater scale. Accident occurred in the busy Gibraltar Straits. It could be catastrophic. Did manage to construct the bridge's piers. Next enormous challenge, building the 3 towers and the road deck. The bridge's sheer size and weight meant finding the right cable system. The designers considered solutions. This was one of them. San Francisco's Golden Gate is a suspended. That means that its road deck is suspended from cables slung across 2 towers. The cable than a mile long. to build, but it's only a fraction of the proposed Gibraltar Bridge. The main cables of a suspension bridge The Storebelt Bridge in Denmark is one of the largest suspension and spans a full mile. Near each end of the bridge, under the roadway, are massive structures known. The blocks extend. The blocks are where the cables are locked down and kept taut. Each main cable 18,600 wires grouped into 37 strands. Each strand is looped around a red steel anchor bolt. Forms a continuous loop from on the other side of the bridge. The other half is a safety backup. It's made from high-strength steel, so it can carry the weight of a 3.5-ton cargo maintained in good condition to stay strong. Engineer Peter Slusk from inside an anchor.
The most important cables in good condition, corrosion, and is dehumidified. Humidity level below a level that steel will corrode.
Work began in 1996. It was done with a special apparatus called a spinning wheel. Tramway that carried strands of wire across the bridge. This perilous high wire act. A temporary catwalk had to be made from thousands of completed of wire at a time. Up and over the two towers, the wires were laid they couldn't overlap or twist, which was wrapped with steel wire, then coated 4 months of 18-hour days, 7 days a week, to spin. They used enough wire to encircle the globe almost 3 times. The bridge would require 10 times as much wire. For Gibraltar's designers, that ruled out the cables would be so long and heavy, it might be hard to keep them taut. The bridge might sag, collapse. So the designers of the Gibraltar had another type of support system. It's called. In a cable-stayed bridge, the cables to the road deck itself, rather than to an anchor block. Brunswick River will soon be completed at a cost It's replacing an old bridge. Ships to pass under. Traffic must come ship through. Under on an average waiting. Of the new cable stay bridge will be over 200 feet above the water, so ships and cars can both move without interruption. Is part of what keeps the must be constructed with great care. To build the road deck, workers must first lay out a grid of steel reinforcement. They will pour a special mix. Construction of this for more than a year. The workers have to pay hours. If they build too far in one direction, the imbalance of weight could designer and contractor are making an inspection. ...450 feet above the water. Overview of the entire worksite.
Yeah, the power.
Completed. The Brunswick River Bridge will be one of the largest cable stay bridges in the U.S. The span of the Gibraltar Bridge would be 18 times longer. To the Brunswick River Bridge's chief designer, there's
anymore.
But the enormous length of the Gibraltar Bridge would make a purely cable stay. The 9 miles of road deck over the straits would require so many cables, the support 1 mile high. That's why the law were built. The Tatara Bridge in Japan, 100 pounds. So the cable stay design wouldn't work for the Gibraltar Bridge either. Some engineers suggested that the very idea of a Gibraltar Bridge was a mistake. They proposed an underwater tunnel similar to the 20 tunnel between England. The tunnel idea had upkeep. The cables on Denmark's Storebælt Bridge and repainted. Then there are those pesky light bulbs. 192 of them, which must be changed by hand.
Vi så en gruppe på 3 mand, som jævnligt faktisk.
We're a 3-man crew. Or if it's windy.
Maintaining a Gibraltar Bridge would be enormously expensive, but to carry only electric trains. There'd be no way to from a tunnel more than 9 miles long. So the bridge turned out to be the better choice after all. Combine the best elements of cable-stayed and suspension bridges. support a half-mile of road deck in a cable stay design. The rest of the road deck in the cable directly to the road deck, but to diagonal base of the towers. But no bridge has ever been this big.
These diagonal struts have to be very heavy. Expensive element of that bridge.
And busiest and most dangerous. Also would raise the women who actually would have to be. Even the calm Brunswick River can be very dangerous.
Not really think about falling.
Workers who would build the Gibraltar Bridge's 3,000-foot towers would be especially Engineer Brian.
On a day, perhaps 10, 15 miles an hour at rough roadway level, but you go up in the air another 3,000 feet, you could be looking at winds in the 75 and 80 mile an hour range, and this will dramatically inhibit.
The Gibraltar Bridge would be pounded from the Atlantic Ocean and dust storms from the Sahara. To survive
of the actual in that very high-speed windstorm, in 150 mile an hour wind, and to the bridge visible, they've all been times. The bridge does exhibit over the suspended span, but the bridge stays in this very big windstorm.
A bridge during construction would be, but it must not move too much.
That's strong enough to stand up and under traffic conditions to be comfortable using it.
That's what happened to the Millennium Bridge in the first new crossing of the Thames in over 2000. People vibrating under them. The bridge actually started to sway as people shifted to keep their balance.
It seems to be swaying.
It was their motion. Bridge. It magnified the bridge's initial much like within days, the bridge had to be shut down. The Army knows the perils of list of bridges. When troops cross a bridge, step and not march. Stepping could start a bridge swaying. Comes to the dangers of high winds, every bridge designer has one famous catastrophe in mind. Puget Sound, July 1st, 1940. Rose Bridge. From the start, the bridge rollicked in that would threaten the Gibraltar. Tourists When the wind speed reached, the bridge had reached. Alone on the bridge stood a reporter covering the sensation. He escaped. But there's another. The bridge almost 4 million tons, and then fortunately, there are emerging technologies which may help engineers lighten the load on from a surprising material. Glass. This very fine filaments. It's woven giant looms. The fabric is made of lightweight foam. Next, scores of individual strands of the fiberglass yarn and fed into a special sewing machine. The foam core and fabric are then sent through the sewing machine which stitches structures in the foam core. Internal strength. Now it's ready for the final step. A special resin is injected into the foam core.
That resin, in fact, is very flexible, and it gives it strength much, much stronger than the glass itself.
Strength on this machine.
We're at 10,000 load pounds. 25,000 pounds. We're nearing failure. That's it.
To flex without cracking is much better than a concrete structure. A sudden crash on a concrete deck is going to. It's very violent. It's very quick and rapid. Fibers, and so the impact only creates a local failure. It won't break the whole structure.
The fiberglass panels were given a real-life test on this bridge at an Air Force base in Ohio. The panels were covered with asphalt, so the bridge looked perfectly normal. Much more durable.
Bridge engineers today are today could last 82.
Enormous. Fiberglass that turns the Gibraltar Bridge from a dream into a reality by promising to dramatically lower its costs. The bridge did get built and become part of a proposal linking all the continents. Would the world become a more peaceful place? Perhaps, but unfortunately, super bridges might also but there are no rules, no traffic cops, no port authority. If a tanker were to crash into one of the piers that support the bridge, it could be a major disaster. The center pier would be the most vulnerable because it is the biggest. The section at the waterline is larger than a football field. Small artificial islands. before it can hit the pier. But that would not be an option.
In the situation on the Gibraltar crossing, the water depth the main foundations, again, we're talking 1,000 feet of water there. So to build an island would really be unprecedented.
Bridge designers came up with an innovative protection device of underwater bumpers. Brand new design that's never faced a real straits. That
You can problem may develop, an engine failure happen, and a ship could possibly run into the tower. And also, in the situation with Gibraltar, you've got water depth surrounding the main towers that is very adequate to carry a ship. So it is a possibility.
The year is 24. A Spanish family is driving, rolling through the bazaars of Tangiers. What they don't know is that the giant supertanker just failed, and 1 million barrels of crude oil can no longer steer his ship, which has now become a 1 million-ton torpedo heading straight for the center pier. Back in the car, the family's biggest concern is whether they'll make it home in time for dinner. But if the tanker crashes into the pier, they'll have much bigger worries. How many thousands lost? Room. The crew throws the engines into 4 miles to bring a supertanker this size to a full stop. Down to the bumper system. Take a hit from a force of 150. Works.